All right, so here we go. This is called binomial expansion. All right, and it also involves something that you need to remember, and it's called a combination. So before we even start this lesson, let's just go back to what this meant. If I said 5C2, it means like there's 5 of you, and I choose to take out 2. Okay, so let's say there's a basketball team. That'd be 5 people. Okay, and you choose to take out 2 of your players. You're going to take them out of the game to give them a rest. Okay, so if you have Bob, and this is a boys basketball team, so Bob, Jim, Alec, Cal, and Zodi. So you got these 5 in there. We can take out any 2 players. Okay, could I take out Bob and Alec? Sure. How many different combinations could I take out? Do you remember how to do these? It's humanly possible at the beginning of a pandemic and all. You may not have ever learned this, but you were supposed to learn it in higher algebra. I feel like you saw it once. Do you remember seeing it at least? Okay, people are nodding yes, they've seen it before. But actually being able to do it might be a completely different thing. Let me show you how it works. It's pretty easy. 5 factorial, which by the way means 5 times 4 times 3 times 2 times 1. In case you forgot that part. Again, 5 times 4 times 3 times 2 times 1. Don't worry, you usually never have to actually multiply all of those out. But that's what it means. Over 5 minus the 2, which makes 3 factorial. And then last but not least, you grab an extra one of these and put a 2 factorial on the bottom. So that would mean 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 with an extra 2 factorial, 2 times 1. And our question about how many different kids could I pull out of that basketball game because I need to give them a rest. I need to pull out 2 of the kids. The answer was 3 times 2 times 1 cancels. And then 5 times 4 is 20 divided by 2, which is 10. There was 10 different ways that I could do that. 10 different combos of kids. I could make a list of all of them. You know, there's Bob and Jim. There's Bob and Alec. I could take out Bob and Cal. I could take out Bob and Zodi. Or I could take out Jim and Alec. I could take out Jim and Cal. I could take out, I don't think you need to see me list all of them, but I think you get the idea. So 5C2 is done with a 5 factorial, a 3 factorial because of this minus this, and a 2 factorial. They simplify, you get 10. All right, let's see if you can do one. What if it was 6C5? There's 6 people. I need to choose out 5 at a time. Hint starts with 6 factorial. Gabby, what do you think goes on the bottom of this thing? Yes, but what's the thing that happens first? This minus this. Yep, and I just don't want to ignore that. That is there, but yes, it's equal to 1. And then there's the 5 factorial, like you said. Good. And then this really means 6 times 5 times, and you'll get smarter after a while. Like, you don't need to write it all the way out. And then 5 factorial means 5 times 4 times blah, 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 blah. And then this whole thing will cancel. So the answer is just 6. Raise your hand if you had that one right. Cool. Okay. Now, let's go to this slide. This is binomials. First of all, why do we call it binomial expansion? Because you have a binomial. The binomial is an A plus B. Could it have been X and Y? Sure. Could it have been 2X and 5Y? Yes. As long as you have 2 separate terms, that's a binomial. If you put it to the 0 power, that's really easy. That's 1. Because anything to 0 power is 1. I'll write it in a color you can actually read on the board. There we go. Notice that I'm putting it in a little triangular formation. See these blanks here? All right, the next one is to the 1 power. A plus b to the 1 would be a plus b. And I'm going to make it more obvious that there's 1's involved. Would you agree it's 1a plus 1b? Now here's the pattern. It's always going to start with 1a. To the something. 1a to a power. In this case, the power was the power of 1. In this case, the power is to the power of 2. In this case, it's to the power of 3. Oh, patterns all over the place. See this little pattern? That, and that, and that go up by 1 each time. Okay. Now I'm just going to erase this for just a second, just because I don't want you to get too confused. But I'm going to show you the outlines of this one pattern. It's kind of cool. I'm going to erase all the A's and B's, just for now. And I'm just going to put, there's always going to be a 1, a 1, a 1, and a 1, all the way up and down the front and the back of that little triangle. See how this, that's a 1, goes with, here, let me use a different color. 1, 1, 1, 1, 1, 1. Those are all 1's. Does anybody know what's going to be right here? Zodi, you are correct. And if you've ever done one of these before, you would know that it's a squared plus 2ab plus b squared. But if you're careful about your coefficients, it'd be 1a squared plus 2ab plus 1b squared. Hence the 1, 2, 1. And this last one is 1, and then what are these two spots? Tobias, have you got the pattern yet?
3.
It's 3. And 3. If you didn't get that, try to look back and see what could he have done to get that. Because he obviously figured it out, did you? You see it now? See it now? If we made one more that had 4 parts to the answer, no, 5 parts, then there's 1's running all the way up and down the outside of it, so it's got to be a 1 and a 1. Sasha, have you figured out the pattern yet?
It would be 4.
4. What about this one? That's not a 4.
5.
6. 4, 1. Do you see where the 6 came from yet? All right, here's the pattern. Yeah, he just saw it. 1 plus the 3 makes the 4. 3 plus the 3 makes the 6. 3 plus the 1 makes the 4. All right, one more row of this. 1, 2, 3, 4, 5, 6 blanks. There's 1's all the way up and down the outside. And then 1 plus the 4 makes 5. 4 plus the 6 makes 10. 6 plus 4 makes 10. 4 plus 1 makes 5. There. Okay. To get that, that's a triangle. It's a famous triangle. Anybody know the dude who invented it? Pascal. It's called Pascal's triangle. All right. So, I mean, he didn't invent a triangle, but he like figured out this was a cool pattern, and it works in binomials for binomial expansions. So this answer, for example, to this problem right here is, I'm going to show you how I get it. A to the second, a to the first, and a to the 0, which is really just 1. And b to the 0, oh, those are not showing up real well. I'm going to use black again. B to the 0 b to the 1, and b to the second. What's that first term? A squared. 2ab, b squared. Okay. I want to go to Pascal's triangle now. Everybody go here. And I'm going to say, if this had been to the 0 power, you would have just had a 1. This is the power now. So if this had been a plus b to the 0 power, the answer would have been 1. If this had been to the first power, it would have been there. Second power would be there. Third power would be there. I'm going to go to the 4th power row. Everybody go to this one and do the same thing I just did and go a plus b to the 4th. And now, if you like patterns, this day is for you. A to the 4th. What do you think I'm going to do next? A to the 3rd. A to the 2nd. A to the 1st. A to the 0. Do you really have to do that? No. After a while, you'll get to be like, oh, I don't need that. And then we can go the other way. Zodi, what's B?
For the first one, B to the 0.
Yep.
B to the 1, B to the 2, B to the 3, and B to the 4.
You are correct. Now, if you can just see these, clean them up in your head. That's really just a to the 4th. That's 4, a to the 3rd, b to the 1. This is 6, a to the 2nd, b to the 2nd. This is 4, a to the 1st, b to the 3rd. And this is just 1. And a to the 0 you don't need to say. So it's just b to the 4th. See how easy those are? Really not that bad. Let's see if you really get this. If I said m plus n to the 4th power, the first thing you'd do is make 5 blanks. Notice it would be logical for you to think there's 4 blanks, but there's not. There's 5. Next, you got to have this like 1, 4, 6, 4, 10 thing, but where the heck do you get that from? If I were you, I'd make my own. 1, 1, 1, 1, 2, 1. Everybody make your own little Pascal's triangle. Get used to it. This little triangle thing was really handy. I'll show you the other way you can get those answers, but you're going to choose Pascal's triangle. I know you are, because it's so quick, it's easy to make. 1, 3, 3, 1. 1, 4, 6, 4, 1. Ooh, that's the one I need. It's got 5 numbers. I need 5 numbers. 1, 4, 6, 4, 1. See how I got that? Now, want me to complicate your life a lot right now or later? Okay. This one could have been found by doing 4C0. And then you would have gone, oh yeah, that's 4 factorial over 4 minus 0, which is 4 factorial. And what's 4 factorial over 4 factorial? It's, oh, and there's an extra 0 factorial, which kind of is irrelevant. But then you end up with 1. And look at that. I got a 1. Do you really want to do that for each of these? I don't think so. This one would be 4C1. And guess what it equals? 4. Could you have calculated that? Yeah, it would have been 4 factorial over 4 minus 1 is 3 factorial with an extra 1 factorial thrown in. And that's 4. And look, it's a 4. So you can get those by using factorials and stuff. And you're going to have a couple in your homework that you have to do that way. But when you don't have to do it that way, then I'd use Pascal's triangle. It's just way faster. Okay. Then, let's finish it off. I go through and do the m's. This would be m to the fourth, m to the third, m to the second, m to the first, and I'm not going to choose to write m to the 0. I'm just going to I'm now smart enough to know, yeah, there'd be an m to the 0, but it's really just 1. So, and then I'm going to go through and do my n's. N to the 0, n to the 1, n to the 2, n to the 3, n to the 4, and then I might be willing to go back and just erase n to the 0 because it's just 1. And there's my answer. That's it. Raise your hand if you got to that before I did. Okay, cool. I think you get this. Now, how can it be more complicated? What if I threw a 2 right there? Well, then you just go through and make it 2m to the 4th, 2m to the 3rd, 2m squared, 2m to the 1st, and there's no m, 2m to the 0, but that's like this. So the whole thing just disappears at the end. Okay, so if I threw in an extra 2, that wouldn't be that complicated. What else could I do to make it nastier? What if this was negative n, aka just minus n? So what if there's a minus in there? Well, then your n's are all just negative. So I go through and make this negative n to the 0, but that's going to disappear anyways, right? Negative n to the 1. Ooh, that means the answer to this term would be negative. Negative n squared, negative n to the 3rd, and negative n to the 4th. Okay. So if you put an extra number there, it makes it a little more complicated. If you make it negative, it makes it a little more complicated. But they're not impossible. I'm just going to clean it up and give you a final answer then. This first one would just be 2m is to the 4th, so the 2 is to the 4th, so that'd be 16m to the 4th. This one, 4 is just a 4. And, oh wait, there's a negative n to the 1, so that's negative n, and the negative will go on to the 4, then it'd be a negative 4m, no wait, 2m to the 3rd, so that's 2 to the 3rd, which is an 8. That part just got nasty. 8m to the 3rd. And then it's just, that negative I've already taken care of. I put it out in the front, so then this is n. And then, yeah, you got to multiply those together. So then that's negative 32 m to the 3rd n. So, remember me saying this is kind of tedious? It's not really hard. It's just patterns, but it gets tedious. So,
something that I noticed is like the factorial one is good to know if you have like big factors, because those can be more easily done in a calculator.
you are correct. So what if we had to do 2x plus 3 to the power of 16? How fun would that be? Not very fun, Mr. Server. Okay, so let's say, do you really want to make a 17 blanks here? You know what I'm saying? Like, yeah, oh my gosh. Would you actually make us do that? Here's a typical scenario. We might say, find the 3rd term of it. Even though you don't want to have to find 17 terms, I get it. You might find the 3rd term of it. So in my opinion, if you're asked to find the 3rd term of it, you'd find the 1st, 2nd, and 3rd term of it. And we know it keeps going, but we don't need to. So if you just wanted to find the 3rd term of it, I want you to do that right now. But wait, you say, how am I supposed to know the Pascal's triangle for, what do I have to do, the 17th row of the Pascal's triangle? No, you don't. As Zodi was just pointing out, you could get this number And we know it's a 1. Don't we know it's a 1? Okay, and eventually it's going to multiply by other things, but, and what is it, like 1, 3, 3, 1? I don't know, but I'm going to go and say that came from 16C0. This coefficient number right here would be 16C1. You might theorize what that is. Anybody have a guess? What do you think 16C1 is? You got 16 people and you get to choose one at a time. How many ways can you do that? 16. Good guess. And the third term right here would be 16C2. Oh, dang it. I'm going to have to do math. 16C2 is really 16 factorial over 16 minus 2 is 14 factorial with an extra 2 factorial thrown in. And that's really, am I going to do them all? No way. 16, 15, 14, 13, dot, 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 over 14, 13, dot, 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 times 2 times 1. And then, watch how this canceling happens. 14 on cancels with that. And the 16 over the 2 would make 8 times 15. All of that simplified down to just 15 times 8. $120. Then I got to do a 2x to the 16th. And a 2x to the 15th. And a 2x to the 14th. And last but not least, we have a 3. At least it's a positive 3. Positive 3 to the 0. Positive 3 to the 1. And positive 3 to the 2nd. So my first term is that. It's 2 to the 16th, x to the 16th. That'd be totally fine with you leaving it as 2 to the 16th. It's massive and it wouldn't be worth writing out. And this one would be 3 times 16 times 2 to the 15th, x to the 15th. And this is also, like Voldemort, one that shall not be named. Just too big, nasty. So I'd be fine with you leaving it that way. And then I asked really for the third term, and I'm finally going to get to it. 120 times 2 to the 14th times 3 squared, which is 9, I might as well do that, times x to the 14th. And there it is. The third term of this binomial expansion. I know this seems like a lot right now, but this will be your favorite test question. It'll be like, it's not that hard. Just plug in some patterns. Doot, doot, doot. Once you get the patterns down, it's easy. And I just did like the nastiest one you could possibly have on a test. If you feel like you followed that, you're in good shape. All right, so let's see if you're in good shape. So we're only 13 minutes in, and last hour we practiced for a half hour. I don't think we need to do that much, so I'm going to just do a few for practice, and let's see if you get this. What if I wanted 3C2? Would you just do that one for me? What factorial over what factorial? L, tell me what you put. What factorial over what factorial?
Over 2 factorial.
3 minus 2 makes 1 factorial times 2 factorial. You are correct. Just showing all of it. Sasha, what'd you get for final answer?
3.
Good. All right. Next, would you please make Pascal's triangle out to 4 rows? Make me 4 rows of Pascal's triangle. Because I bet you're going to choose that option to get those lead coefficients. Tobias, you got this? 1 and then,
For the fourth row?
no, just make me the whole triangle. So after, underneath this one?
Then 1 and 1.
Yep,
Then 1, 2, 1.
yep,
Then 1, 3, 3, 1.
perfect. And that would be like doing x plus 2y to the third. Everybody use those coefficients you just made and tell me what x plus 2y to the third is. Amelia, start with x to the third and then what? It's just a bunch of x's going like this.
X to the second,
Yep,
and just X to the first.
Yep.
X to 0.
do you have to put x to the 0?
No.
Nope. All right. Miss Paul, can you handle the 2 y's?
Is it just 2y power of 0 for the first one?
Yep, and you put it in parentheses like this to make sure that both parts get put to the 0, so that kind of just disappears. And then, what's the next one?
2y to the first power, 2y to the second power.
And I'm putting it in parentheses because do you get a lot of people just hear 2y to the second and they don't think about how the 2 is actually going to get squared? So I'm going to keep putting it in parentheses. And what's the last one?
2y to the third power.
So it's really not going to be 2y to the third. It's going to be 8y to the third. And then, would you please clean up these final answers? Any kid who leaves it like I have it right now will get it marked wrong. That is a huge math problem. It's not done. Jake, can you? What's this first one?
First one is x cubed,
Yep. How about the next one?
3x squared times 2y.
So we'll put the numbers together and give me a final coefficient. It's not 3 anymore.
6.
6. Keep going.
X squared times y.
Yep. And is it positive or negative?
Positive.
Yep. So we put a plus 6x squared y. Cal, next one.
Plus 6xy squared.
Close, not 6 though, because that 2 has to get squared first.
12xy squared.
All right. 12x y squared. Yep. And Tobias, the last one?
8y to the third.
Yep. That's called a binomial expansion. Okay. I think we should go and just do like a problem on each page because I feel like you get this now. Time will tell. Let's not do this one, just a little too gruesome. But you should be able to fly through this. Nora, how many blanks should I put?
5.
False. 6. So it was one more. That's the reason I'm practicing though, because a lot of people will, on the test, put 5 blanks and they'll be like, why is this not working? Needs 6 blanks. Olivia, are you going to do this with Pascal's triangle or with like this spot is 5C0? What would you pick?
Probably 5c0.
Pascal's?
Rather 5c0.
I can't understand what you're saying.
Let me just run.
So what do you think I should put? Like 1, 3, 3, 1 here? What do you think these numbers are?
Maybe 1. And then 5.
How'd you get that? Pascal's triangle?
Yeah.
Ah, so you're using Pascal's triangle. Okay, that's what I was trying to ask. 1, 5, 10, 10, 5, 1. Okay, good. Sasha, what's next? There is options. What do you want to do next?
I started with the x's, and in the first blank I put x to the fifth,
Doing good. Keep going.
then x to the fourth, then x to the third, then x to the second, then x, and then nothing.
Okay, good. And then the Y's. I think you're still on the hook here, Sasha.
Yeah, so, for the first blank I put y to the 0, which
Yep.
is just nothing. Then y squared, then y to the third,
Yep.
then y to the fourth, then y to the fifth.
And then you just have to clean it up a little bit, and then you've got it. Raise your hand if you feel like you get this. Cool. Tell me what would have been different if this had been minus y instead of regular y. Miss Paul, do you know what to do? Let's just tweak our answer. Make it minus y.
The first one would just be 1, and then
Because it's minus y to the 0, which would be 1. Okay, keep going.
the second one's just negative y.
Now it's a negative y, so what does that do to our answer?
Negative.
It makes it negative right there. So this first one would be x to the 5th. The second one would be negative 5x to the 4th y. And then this becomes negative y squared. And this becomes negative y to the 3rd. And whether it's to a degree that's even, then the negative gets canceled. Or if it's to a degree that's odd, then the negative doesn't get canceled. So this one would be negative 10 x squared y to the 3rd. Why is it negative? Because it was to a power of 3. And this makes it negative y and negative y. And so this was to the 4th. I don't know how my 4 disappeared. And then this one, the last term, for example, would be negative y to the 5th. Might as well fill in the second to last one, 5 x y to the 4th. Positive. Okay, I feel like you're getting this. On this page, they're just seeing if you know how to do these. I know the answer already. Do you know the answer yet? Because I just go in my head quick, what's happening? Cancels, 7 times 6, 42. Makes sense? Okay. If you understand this, you'll be able to tell me the answer pretty quick. Almost everything cancels, right? Wouldn't that top one be 1,000 times 999? And then the 998s and on will cancel, so it's just 1,000 times 999. That's not that bad. Oh, wait, but there's a divided by 2. So then I could take my 1,000 and divide it by 2. And it'd be 500 times 999. Or I could have done times it by 1,000 and then divide everything by 2. So this would be 999 with 3 zeros, all divided by 2. That wouldn't have been too hard to do either. Same answer. Okay, on to this page. This is just telling you how to get those coefficients. This one would have been to the 5th power, and this would have been the 4th term over. And that's how you would have got the coefficient. Let's talk about that a little further. So let's say we had something to the 5th. X plus 2 to the 5th. And you go, well, I know there's 6 blanks. I don't want to make Pascal's triangle. So let's say Mr. Server only makes me do this one. find the second term. The first one would have been 5, choose 0, which would have been 1. The second term would be 5, choose 1, which is 5 factorial over 5 minus 1 is 4 factorial with an extra 1 factorial, and then, yay, that's just 5. This one would have been 1. And my advice to you, do both the first and the second term, and then you'll be able to easily keep your pattern going, you know? Don't try to do everything in your head. This is x to the 5th, then x to the 4th, then you don't have to keep going. And then you go, oh yeah, and then I do the 2. And then it's going to be 2 to the 0, 2 to the 1. Ah, sweet, I'm done already. 5 times the 2 is 10. 10x to the 4th. Raise your hand if you had that before I did. Sweet. Okay. Then, here's Pascal's triangle again. Advice, word to the wise, take a screenshot of that. Do you get if you need this row, you don't want to have to recreate that all by yourself? Just take a screenshot of it. Now always remember, the first row is to the power of 0. Anything to the power of 0 is 1, right? So this would be for the power of 1. This row is for the power of 2. You know, there's always one extra blank, more than the power. So this is power of 2, and I had 3 spots. Okay, you have work time, you have problems. If you're wondering what this means, it means this is 1 bigger in factorial than this is. It's like 99, 1 bigger than 98. If it had been 99 factorial over 98 factorial, can you figure out what the answer would be? Come on, if it had been 99 over 98, it would be 99, wouldn't it? So isn't that the original starting number? So if this is 1 bigger than that is, then the answer would just be n. That equals n. What if it's 2 bigger? Well, that's kind of like being 2 bigger, 7 factorial over 5 factorial. And you get the answer to this one is just 7 times 8. So the answer to this would just be n times 1 bigger than n. N times, what's 1 bigger than n? Don't change letters. N plus 1. If you don't get where that's coming from, I get it. You should make yourself an example and go, it's 2 bigger than the one underneath it. So like 100 factorial over 98. And then you pretty quickly realize that, oh, it's just really the first 2 numbers, which is 100 times 1 bigger than 100. Or sorry, 1 less than 100, which would be 99. Uh-oh, wait a minute. Then this one will be n minus 1. If any of you said it n minus 1 in your head, I apologize. Yeah, it is. It's n times n minus 1. Okay. So this is 100 times 1 minus that. Or 100 minus 1. Okay. Use Pascal's triangle to expand the given binomial. I would personally make 6 blanks for this one. And you're off and running. I'd use Pascal's triangle. On this one, it's just more complicated because it's, instead of x going all the way across, it's 1/3 x to the 0, 1/3 x to the, well, wait a minute, sorry. 1/3 x to the third, 1/3 x to the second, 1/3 x to the first, 1/3 x to the 0. And it's got a minus in it too. And those are the hardest two problems on here. So we've already can't handle stuff like that. That's about as bad as it could get. This little x to the -1. Do you realize that x to the -1? So many people forget their powers. Do you guys know what that even means? What is x to the -1? 1 over x. So that's like they included a little 1 over x right here. 1 over x. It's a power of 4, you make 5 blanks, and then it's just tedious. The x is easy, but the 1 over x is also negative, and that's going to be tedious, but you can do it. 1 over x to the 0, and it's negative. 1 over x to the first, and it's negative. Why? Because there's a negative right there. So there's a negative right there, really. Okay, that's all I have for you for today.